Good afternoon. My name is Peter Goodwin. I know I'm between you and the next break, so trust me, we are not going to overrun. We're going to talk about taming hybrid cloud, the complexity you get with it, and specifically around a viewpoint from Efficient IP and our DDI platform. We sell DNS, DHCP, and IP address management, so there may be a flavor of that within this presentation. So just a bit background for me. I'm from the UK and therefore suffer from our education system, and we barely learn one language, which is English. So unfortunately, I have to do this in English. I run the pre-sales for Efficient IP in Northern Europe, Middle East, Africa, and India. So I just want to set the scene on some of the issues that customers are having with hybrid cloud and actually deploying it. Some of the ways that we think you can at least try and allay some of the problems, and a couple of best practices along the way. It's not a massively long slide deck. We'll try and get through it in about 20 minutes. So there's a massive increase in the number of devices that are attached to networks today. That's IoT devices, it's more machines. Applications aren't just stuck in one data center anymore. They're very distributed. There's cloud-based, there's SaaS, there's private cloud, public cloud, and the old servers as well. So the applications are being more and more distributed, which is also on top of fragmented networks where you've got public cloud, private cloud. You might have multiple cloud suppliers for public cloud. So there's more networks and more types of networks that you need to deploy services on. And the threat landscape, which I didn't really pick up on a lot of the presentations before, but mostly it's all about increasing threats within the network, and they're not going away. And I think it's Gartner that did the report where they say that 90% of all organizations by the end of 2027 will be adopting some form of hybrid cloud. So it's not an edge case anymore. This is mainstream technology that people are deploying and trying to live with. And there are challenges along the way that companies are hitting. The fragmented network. Now, a lot of the time that's because you're just talking AWS or Azure and ESX on-premise, the old physical networks. And if you don't have centralized IPAM, how do you know what's connected to what within the network? And if you want consistency across all environments, one thing to consider is what you're doing with DNS. Because you want the same experience no matter where a client is within the network. And some of the things you can come across are things like overlapping IP ranges. It's not necessarily a problem. Sometimes it's by design. But you can get conflicts. And if you've got duplicate IPs on a network in the same area, that can cause problems. It also makes planning, allocation, and kind of just looking at what you've got a lot more difficult. A lack of automation or insufficient automation is a problem for a lot of customers. And that's not just when the first point, integration with DNS, DHCP. It's about commissioning, provisioning, and then decommissioning services along the way. If you don't automate that stuff, it takes time, takes effort, and it's prone to manual errors when people are doing it. It can also increase the time to service that it takes to deploy something. If you've got to manually ask someone for an IP address, or even if you put it into a system, but it goes into someone's queue, they then have to go to a spreadsheet, pick out the next free IP, tell you what that IP is. And then you may have to go to someone else to create a DNS name so that you can access it, because not many people are going to remember all the IP addresses. That just increases the amount of time it takes to do something. And if it is a manual process, a lot of the times things don't get cleaned up very well. So it can be a bit of a slow kind of process if it's not automated. And if you're not looking at the way that DNS is deployed across all the environments, it can be inconsistent. You could end up with a lack of visibility in different environments, because you might manage Azure DNS in one place, AWS in another. You might have on-premise DNS running on Active Directory, but then you've got external DNS running on legacy equipment. And keeping all those things in step and consistent becomes a bit of a challenge. It also means you can't really roll out any security policies based on DNS if you don't have a common way of addressing all the environments. And I think EMA, with the analysts that actually polled a bunch of existing customers that have gone through hybrid cloud deployments, 25.4% said, yes, we've been very successful in doing it, which is good. A quarter of the companies polled actually were very successful. The biggest one is the partial success. They didn't achieve everything they wanted to achieve while they were going through their hybrid cloud deployments. They don't really go in on these slides. We're not going to go into the details. That's in the report. If you go to EMA, you'll be able to pick it up. But it's an interesting point that 4% had a partial failure, but 70% nearly, they say it's a partial success. So that implies there's some failures there. And then in a separate report, EMA put this statement out, and they recommended that network automation was something that customers should look at to help streamline operations and to make consistent positioning of standards across the network. And then there's another report again. Sorry for the amount of reports from EMA. I'm not advertising for them at all. But cloud automation and hybrid cloud deployment were the top two reasons why people were driving network automation within their organizations, because they see this as the way to help with hybrid cloud deployments. So given that, what can we do about it? Well, we look at it as having four basic tenets that you need. One is core network services. So that's DNS, DHCP, and IP address management. And if you put those onto a centrally managed platform with distributed service, you can get the visibility of what's connected in the network. And that means talking to the different networks to find out what's in there. Because if you want to know what's connected to a switch, the best thing you can do is interrogate the switch and pull the topology information. Same for a router. If you want to know what routes are on it, ask it. It'll tell you. You can do that with the cloud environments. You can go to Azure and say, I've got this subscription. Please tell me what tenants and what servers I'm running on it. You can do it with AWS. You can do it with Google. With all the cloud environments, you can get that information. So you can pull it out of a siloed solution and bring it into one place. That helps you with visibility. It also helps you if you want to speed up deployments into those things. The network automation part is where you do that discovery. You bring it all back in. You start to reconcile any conflicts that you've got. And you just try to integrate more with the ecosystem that you've got. Everyone spends a lot of money on siloed products that are probably best in breed of what they do. And on their own, they're really good products, but they work a lot better when they're connected. You get more value from what you've already bought if you can integrate them in any way. So the network automation side just helps that along. And then we believe that you need to put adaptive DNS security in the network. So every transaction on your networks is kicked off typically with a DNS request. There are some hard-coded IPs still in existence, there always will be, but mostly systems connect by issuing a DNS request, resolving the name, connecting to that IP. So it's a really good control point to put security policies in place that you can look at what the query is doing. So you can look at reputational data, you can consume millions of records of threat indicators from various places. We sell some, lots of different companies sell third-party feeds that have newly observed domains, new domains that have only been seen in the last week or so, because no one releases a service with a domain they registered yesterday. So they're normally a good thing to see. But there's spam filters that can give you the domains known associated with spam, phishing, ransomware. There's a ton of different feeds. You can run those on the DNS server. You track every single query against a list of known threat vectors. If there's a match, you can inform the security, you can block it if you want, you can rewrite it. There's a number of things you can do, but you're aware of it at that point. You can take it a step further and look at what individual clients are doing with DNS. Now, most malware, when it tries to let data or leak data out of a network, a lot of it will use DNS. Because for your DNS queries to resolve on the internet, port 53 has to be open. And everyone knows that. So if they can create a DNS request that's a valid request, it's probably never going to trigger any threat data because they'll use a domain that's only live for one day. So by the time it's been identified as a threat, they're not using it anymore. And they'll craft a DNS query with encoded data that will leave the network and get to a compromised DNS server where it's decrypted. And when you look at the amount of queries that anyone's network is generating, it's thousands of queries per second. It's a large amount of data. You can't process that easily and quickly. And it's stateless. DNS doesn't retain state. It's fire and forget. But if you want to do this kind of thing, you've got to start putting stateful measurements against individual clients. And then you can see when anomalous queries come up that might indicate whether it's exfiltration or not. And then the last thing is intelligent app steering at the DNS level. So being able to health check resources and only return valid records for those resources when someone queries them. So if you've got 4 web servers, one's down, and you've got 4 records for DNS, returning the 3 good ones and not returning the one for the server that's offline. That just helps people maintain service a lot better and also enables very quick disaster recovery if a service goes down. So that's where we think we add a little bit of value. The centralized management, well, we can do the overlay management across multiple types of service, whether that's Microsoft Active Directory, Linux-based DNS DHCP, our own DNS DHCP. But that just gives you the central visibility of what's running on core network services. From an IP management perspective, it's about pulling all the relevant information from the likes of Azure, AWS, Cisco Meraki if you're using that for Wi-Fi or whatever, getting it into a central place that you can then use as a source of truth. Helps with the consistency, helps with the scalability, and it will simplify DNS management and the policy enforcement that you can put out with DNS. And it is that network source of truth that enables automation. Because if you do get all the information into one place, your orchestration platforms can then integrate with the IPAM or the management platform that's providing that network source of truth and enable things. You can pick up the next free IP range, the next subnet that's available. You can pick up the next IP address or a number of IP addresses. You can template a deployment and actually just create both the network, the IPs, and the names that you can then spin up and access instantly. That removes a lot of the inconsistencies and helps with the error checking of putting things through the system. The fact that you're talking to all the different systems allows you to actually resolve things and do the data reconciliation if you need to. And then if you've got an open API on top of this, you can pull this information and push this information from any other system that supports a web API. That helps you tie up all the silos together. And we look at it from an ecosystem point of view where we integrate with all of these plus a few more around the kind of the edge of what we sit in the middle as IPAM. Because that IP data is kind of key to everything that you're trying to automate. And it just helps connect all those tools together. And you can do various integrations with our platform, whether it's no code, low code, or pro code, depending on how much that integration gets in complexity. I mean, there are certain integrations built in today where if you've got ServiceNow, you can create an IP reservation very easily. But then one key thing is having the observability about what you're doing within DNS. As I mentioned, people generate thousands of queries per second in their organizations. You cannot log all that information really easily. If you start logging DNS queries, it kills performance. So you need a way of aggregating the data. You want to make sure you capture what's being queried. You don't necessarily need to capture every single query. But having the ability to look in to what's going on at the DNS level, understand whether or not DNS is working okay. I mean, if I was sat in my network and I had a cache hit ratio of 8%, I'd have a bit of a problem. Because that should be around 95, 96% in most organizations. This is from a test environment, so it's rubbish. But getting the metrics that allow you to see whether or not someone's attacking you, getting the metrics to see what hits are being seen in DNS against threat data, what hits are being seen that seem to indicate tunneling or data exfiltration or infiltration. And there are valid reasons for using that kind of technology. Most antivirus uses DNS data infiltration so that the endpoint clients can download the updates. And they use DNS for it because port 53 is open. They don't have to worry about the firewall rules. But being able to see what's going on becomes key. You can't secure what you can't see. So the observability is something that you need to have somehow in the network, whether it's through Grafana and some fancy graphs, or whether it's just pulling SNMP statistics and displaying them in Cacti. It's something that's worth looking at. So the way we look at it, and this isn't exhaustive, but it's starting with DNS, DHCP, and IP address management as a basis. It's not the only one. It's just a brick in the wall of hybrid cloud, but it helps start is having that single source of truth. So doing that and then basing the provisioning on that, putting DNS, DHCP on top and automating that for a consistent experience across all environments. So deploying DNS into AWS or Azure with the same policies that you've got on your internal network or on your ESX network, so that every client has the same protections, the same policies, the same experience. And then just prioritizing management of the IP address across all of those. Again, not exhaustive, but it's a good start point to enable the rest of the things you need to do. So just as a key takeaways, we look at this as if IPAM is the start and DNS is the second thing, that starts to give you, if you've integrated it with the cloud and the physical network, a single source of truth. That helps automation, also helps give you observability in the DNS, which is something else that you need. That will help to have a successful hybrid multi-cloud journey. Or at least that's what my marketing department tell me. Thank you. Any questions?
What else do you get compared to like web filtering or URL filtering? What more does DNS security bring?
So typically, if URL filtering is still needed, because we look at the domain, not the full URL. But if you look at a decent DNS server, you can look at millions of individual threat actors. Most web filters don't have the same amount of coverage in what they're blocking. And if you're looking at non-HTTP traffic, which is what most malware will just issue a DNS request, right? That's not going to touch the web filter. It's going to go to the DNS server that you get when you get a DHCP IP from the DHCP server. It's going to give you 1 or 2 DNS servers. Malware is going to use those to send the queries that are going to leave the network. So it doesn't actually touch the WAF. So it's complementary. It's not a replacement, because you still need to be able to do the URL filtering, but it looks at the non-HTTP based traffic, which a lot of the time you just don't see leaving the network. And it also, you can use DNS on the internal network for east-west traffic, where it's looking at reconnaissance. So most malware will touch a network, but it's never the first point is what it wants. It wants to get somewhere else. And it will do reconnaissance within the network. So if you can look at the east-west traffic, which again won't be touching the web filter, then you can start to apply control at that point. Does that make sense? Any others? I'm looking at a lot of blank faces. I know I'm in Finland, but it's a lot of blank faces. Okay, thank you.